A roundtable of Q&A with Josh Newman, Vice President, Client Computing Group, General Manager, Product Marketing and Management at Intel.
What is Intel's marketing strategy as far as graphic cards is concerned?
Yeah, so we really started with the first discrete product recently with the Intel Arc discrete GPUs. So we're establishing the Intel Arc brand on a discrete GPU for the first time. I mean, we've been doing GPUs and built into chipsets and then processors for well over 20 years, but we never really established a GPU brand based on that because the discrete, NVIDIA and AMD with their discrete product lines really established from the performance halo part, and then they drive their brands down. So for us to really establish a brand, we believe that entering discrete graphics was important, so we started Intel Arc based on that. Now, as we use the same architectures into our integrated products, starting with Meteor Lake and now with Lunar Lake, we'll continue to use that same Intel Arc brand and have levels of it. So as our roadmap goes through time, you'll see more of that integrated GPU brand being used, but being lifted up by also having the discrete graphics options.
Intel's graphic card marketing, and especially ARC models, are hardly known in Israel. What plans do you have to advance selling graphic cards?
Yeah, it's a perfectly fair question. Look, we're coming in as the third player in the market. It's going to take us a little time to establish, and then, as we build momentum, we'll continue to put more energy behind that marketing that goes to customers. What was important for us was to get in the market, start to build the brand, show a differentiate, to show an advantage around software quality, to make sure we're bringing the developers to the platform. That's the other really important part about having a discrete GPU, is that the game developers paying closer attention than they would if it was integrated. It also makes it easier for them because they can switch between GPUs on one desktop system instead of 10 different laptops when it's integrated. So we're starting there, and we are starting relatively small because it's a big hill to climb, and we're going to take it step by step. But it is, as we go through time, we expect to see more from us.
If you look at product management of the future CPUs or SoCs from Intel, especially when we're looking at these thin and light notebooks, if you would draw 3 circles, one for the CPU, one for the NPU, one for the GPU, which one will increase the most in the next iterations?
I'd say CPU. Well, CPU has always been our primary focus, right? Like for 45 years of being in PCs, the CPU has always been the core focus. GPU is getting a lot more attention now. So I'd say if you just want to look at like rate of increase or rate, it's probably the GPU is a big relative focus. It's not that we're taking anything off CPU, but putting more in the GPU. The NPU also extremely important. But with the NPU, it's less about being a performance IP, and it's really that low power efficient accelerator. So we want to make sure we're putting the right tools, the right frameworks, the right power efficiency into the IP. But I'd probably say in that order. I mean, as far as rate, if you look at it from where do we put most of our energy? CPU today, GPU second, NPU third. If you look at the rate of growth in terms of where we're putting more, relative to prior years where we're putting more, it's GPU and NPU are obviously growing because they're new. They're newer. Well, their focus on pushing the GPU to higher performance levels is newer, and the NPU is new to the PC.
And if you look at hybrid AI models, which is obviously one of the targets for Lunar Lake, is 16 gigs enough?
It depends on the model. For most models, the answer is yes. There's going to be obviously some large language models and extra large language models. You start to get to having multiple 7 billion parameter models or 30 billion parameter models and 120 billion parameter. Now we're starting to get to, these are maybe more data center first models. Maybe they'll come to the client over time, and we'll go look at the right memory requirements. And that's not just a capacity statement, it's what's the right bandwidth, what's the right speed, so latency, all those things matter. But for most, you look at the 500 plus models that are enabled on Core Ultra on Meteor Lake, 16 gigabytes for those is enough. Also in
2 years?
Again, that depends at a given system level. I think there's two forces happening. One is that the developers are actually working to make their models smaller, higher quality and smaller. So they're actually trying to make the software more efficient and need less hardware. But the other thing is like the user experience of running multiple AI experiences on a given system, those may then gang up, and that require like a different approach to the system design in terms of memory capacity, memory bandwidth, and so forth.
The question is, in my case, what are the changes except for the core count that does? That's the obvious difference that's going to be for the more powerful Lunar Lake versions in the future. Are they going to be the same thing with the GPUs, because you'll consider them to have like the H models that are specifically made for external GPUs? And in that case, I'll assume the P and E cores will be the same because the design. But what is the direction in the later Lunar Lakes that are going to be? Because again, the Vs are very specifically made to compete with the ARMs and the Apples.
Yeah, you're asking a question that we're not answering today, and where the embargo lifts tonight at 6 o'clock. You're asking questions about products that we'll announce in the future and share more details. Now, inclusive of, I don't know, you're joining us tomorrow for the...
Should be, yes.
Yeah. So tomorrow, we have a different, similar to, it's like a miniature of what we did in Computex with ITT.
Yeah.
We're going to share more of the architecture of what's next. And so your question, a lot of what you're asking will get answered in tomorrow's session, but that will be under embargo till October 10th.
Yeah, I know.
So, but it's just to give you a taste of it now. So, yeah.
In 2013, Intel announced getting out of the motherboard market. In recent years, Intel stopped making the Great Nuke line of small form factor computers. What leads Intel to leave such an important segment of the computer industry?
Yeah, it comes down to prioritizing where we spend our innovation resources and investment dollars. What we saw with NUC, we were very proud of the NUC line. I'm glad you liked it too. That was a very hard decision to make. But what we were looking at was we had a partner in ASUS, as well as some of the other OEMs that were innovating, that had sort of picked up on that innovation and were going as fast, or maybe had the potential to go faster, because it is their competency. Including the whole distribution, the go-to-market, everything else with it. And so when we saw that and we had to make decisions about, can we move investment from this product line into maybe doing more on GPUs for the processor? Like, those are the kinds of decisions. So it just came down to investment priority decision, and the fact that we found a partner that could do it the same or better than us and support our existing customers in that transition. The motherboard exit was a similar decision. We had always said we were in the motherboard business for years and years to sort of show the way, to accelerate the innovation, to help catalyze the open ecosystem. But we never wanted to be in a position where we competed with our customers. So we were always very cautious about how we entered that. But the same was true in the NUC, right? We wanted to be very focused on specific spaces and not get in the competition with our customers. What we saw by the time we got to 2013, impressive historian, by the way, was we weren't really showing the ODMs anything anymore. They were better at it than us, or they were at least as good at us. So the original intent to be there, with the risk it creates of competing with your customers, we just figured we would be better served just enabling our customers directly.
But how do you look at USB 4?
Well, I think we contributed a lot to the USB 4 standard. We think it's important to contribute to the open standard and bring the innovation. Like, Thunderbolt in a lot of ways is it's a whole end-to-end specification that USB 4 doesn't cover. So with Thunderbolt, you can get more assurance that from both sides of the link, everything is tested, verified, and validated to work together at high speeds, manage the experience. That's the advantage of Thunderbolt. But being able to then be ahead on the Thunderbolt innovation and be able to contribute that to the USB Implementer Forum, so that you can also have a broader open ecosystem, we think is a really important thing. So we look at them as coexisting. We think the USB 4 is important. We think the open standard is incredibly important, and we'll keep contributing to it.
But you're not integrating it in the Lunar Lake chips.
Well, any Thunderbolt port is USB 4 compliant. And pretty much every design is using Thunderbolt. Because it's integrated, we've made it easy for the OEMs to deploy. But then it can connect up to any USB 4 device, right, and be guaranteed by spec to work.
Is there any chance or intention of having dedicated NPUs?
I mean, sure, there's a chance. We have a really strong team building that IP, and it could be implemented as an integrated unit like it is in the Core Ultra processors. Actually, 2 years ago, we did a discrete version using that basic same architecture. It was called Keem Bay. It's more of a software development vehicle, similar like what we were talking about with graphics. So we have done it where we've done that kind of discrete thing. And then for that, it was more like it was a PC usage we were envisioning before any NPUs were integrated into PC processors. But it became a really useful software development vehicle ahead of Core Ultra being available to ship full systems to the ISVs. It's part of the reason we actually have so many models already optimized for Core Ultra, is that we had that head start. But we'll also look at other markets that can benefit from the IP work we're doing in the client space.
What's next after OpenVINO, basically?
Yeah, and I think you heard Rob and Carla talk a little bit about this when one of the questions was asked today. The goal is to make sure we have a breadth of frameworks supported. They may not all give the same performance, but different developers and ISVs are going to want to just have different programming environments and use different models. So we want to make sure that if they choose WinML or they choose OpenVINO or different frameworks available, that we'll get as much optimization underneath those frameworks down to our hardware as possible. Our advocacy when we first talked to ISV is, hey, for the best performance, we're furthest along with OpenVINO, right? And we believe the power of the openness of OpenVINO is really important. And so for ISVs to choose that, there's going to be access to probably the best tuned performance we have to our NPU. But we're also making really great progress, for example, with like WinML to bring specific optimizations there and improve the performance for ISVs that choose that.
But are we going to see AI accelerators on the server market that's going to compete against NVIDIA?
I am not a qualified expert to talk to it, but we just launched Gaudi, the Gaudi 3, right? So that's a focus, but definitely not my area of expertise. It's our.
I can follow up with you as I'm part of these AI comms, and we can schedule something for both Gaudi 3 and we'll also announce Flatten Shores as the successor, using XE IP and also the goodness of Gaudi for next year. So happy to put you in front of the right people.
Is there any progress with the power consumption, in light of the new ARM laptops, in the new Lunar Lake processors?
No, so Lunar Lake, we showed 50% SoC power reduction versus Meteor Lake, 50. Right? So it's a huge power reduction. And then we also showed several data points relative to shipping Qualcomm platforms where, depending on the workload, we're either better or a little worse, but it's kind of, it's absolutely busted the myth or idea that you have to have ARM to get that kind of battery life.
Yeah.
So we showed all that. And then if you're in, I would just say, like, your questions about kind of, as if you're coming to the 6 o'clock event tonight, you'll see more.
Okay. Also, do you check out the demos where you have a live presentation, where we have different Lunar Lake SKUs at different power levels, and comparing them to both Qualcomm and AMD, and you see that even at lower power we can deliver higher performance, and then if we crank up the power consumption, we can also achieve an even higher frame rate. So it's very good.
Yeah.
Intel, at times, confuses the IT and consumer market by giving confusing names to each CPU. For example, Raptor Lake Gen 13, Raptor Lake Refresh Gen 14. Why doesn't Intel stick to a single name convention?
Yeah, because it's hard. Well, the interesting thing was we were on 14th gen, all right? So it was at some point, there were a couple things we were trying to do when we shifted to Meteor Lake. We wanted to make a change to Core Ultra to signify the beginning of the AI PC, that there's something new in these processors. And so we just started the numbering over from 100 series. Right? And the idea is to now, it's very, very simple in that construct. So Meteor Lake is Series 1. The processor numbers all start are 100 in the 100s. Lunar Lake is the beginning of Series 2. The processor numbers will all be 200. You could imagine other things you're going to hear about tomorrow and the next few months will also be in that kind of 200, right? And go from there. What we thought was important, mostly for consumers, was what was our old branding construct was causing some interesting confusion around what's more important, the 14th gen, the brand level, the core, the I, because we used to do core i3, i5, i7. Right. What we found was we wanted customers to really anchor first on Core Ultra. And I'm really talking about the consumer market now, like the broad consumer market. We wanted to help them. If they know they're looking for an AI PC, they should just look for Core Ultra. That's point one. So we wanted to simplify, like remove, so don't lead it with a 15th gen, blah, blah, blah. We wanted Core Ultra to be the first thing. And then as far as the levels, which is the next key cue for how much of it do I buy, whether it's a 5, 7, or 9, we just had to get the I out of the way, because a lot of the shorthanding was, instead of people talking about Core i5, they would just say i5 or i7, and you totally lose the core. And so now if a consumer is looking at an article about this great new i7, they go to the store and they, I need the i7, but then maybe a competitor brand also has a 7. We need to make sure the core is there. So that was sort of our approach. In simplifying branding, it's snap to Core Ultra, start over at 100, right? And now run that and try to drive simplicity off of that, right? But yeah, I think the last point is, it was after 15 years of the old construct, it did get confusing, and that's why we felt we needed to reset so we can try to start over and make it simpler again.
Thank you, guys.
Thank you.
Thank you.
Okay, thank you very much.
Yeah.
Yeah.